Welcome back to our YouTube channel. My name is Navasa Roderick with my colleague Ahewa Steven, presenting to you the continuation of our project football prediction and how we can use AI to help us in predicting football results. Yeah, so football prediction data sets. This is a link to the dataset I am going to use for this project. It is here. I think in case you want to have any refer, you can follow the link to get the dataset. So the dataset is composed by season, country, and league, the date on which the game was played, the name of the home and away team, the number of goals scored by the home away team, goal difference, and the outcome of the game in terms of win, draw, and away win. The next step is to filter all the features into one that affects the result of a soccer match. Uh, this was proved that player attributes affect directly the predictability of a model and demonstrated that the features such as goals, shots, corners, attack strength, manager performance, streak, and managers win increase the accuracy. Factors considered before selecting the dataset. Availability. Your database engine must have the ability to be highly available. However, that may come that may come at a high price. For example, clustering or adding nodes will always increase the hardware and software cost. Yeah. So make certain that you understand the topology of the hardware architecture and associated costs. Disaster recovery. You should review your disaster recovery plans to make certain your database engine meets your requirements and required software. Yeah. And if it takes too long to backup and restore, you may not want that engine. Or if backups aren't an option, and you need to restore or recreate a bunch of flat files, you will need you will want to know that before the disaster strikes. Yeah. Then there's performance. One of the most nebulous statements out there today that databases don't perform well. You must understand the ratios of reads to writes. If your database engine is designed to maximize one or other, also you need to consider that the fast database performance may be a result of a trade-off somewhere else. So, for example, you may be promised amazeballs transaction velocity, but in the result, of a weaker consistency. If you need a stronger consistency, then you may not get the throughput you are promised. Business support. At the end of the day, if you don't have a champion for your choice of database engine on the business side of the fence, then your project won't go anywhere. Important features in the dataset that our AI model will use: ELO rating, team performance parameters, betting odds, the performance match results, the number of goals scored by the home and away team, offensive and defensive performance, the home effect parameter. Then another is attack parameter, overall quality of the team, the quality of the opposing team, performance indicator. This depending on the quality and quality of the opposition. Presence, presence and absence of players, venue, playing positions. Um, Another is attack parameter, overall quality of the team, the quality of opposing team, performance indicator. This means depending on the team quality and the quality of the opposition. So the present stroke absence of players, venue, playing positions involved. So by Bayesian theorem, what I understood from Bayesian theorem here, it describes the probability of an event based on the prior knowledge of conditions that may be related to the event. It relates conditional probability and marginal probabilities of two random events. Bayesian theorem derivation. Proof of Bayesian theorem derivation, the probability of two events A and B happening. So the probability of A intersection B is the probability of A, uh, which times the probability of B, given that A has occurred. So which will be equation 1. Then on the other hand, the probability of A and B is also equal to the probability of B times the probability of A given B, which is equation 2. So when you get the two, when you get the two together, you end up with a third equation. When you first, yeah, you end up with a third equation, and thus the fourth equation, which is Bayesian theorem, which will be the probability of A given B is equal to the probability of A times the probability of B given A out of the probability of B. Yeah, this equation, which is known as Bayesian theorem, which is the basis of statistical inference.
My name is Iowa Steven, and to continue from where my colleague has stopped, we are looking at the naive Bayes. A naive Bayes is a classification technique or algorithm that is based or that follows the Bayes theorem, which is an assumption of independence among features in data. We are looking at Bayesian networks. Bayesian networks, also called the Bayesian belief, falls under the category of probabilistic or graphical modeling, a technique that is used to compute uncertainties by the use of the concept of probability. Now, the uncertainties that are computed by the use of the concept of probability are the direct acyclic graph are modeled using the direct acyclic graphs and the conditional probability graphs. Here, the Bayesian network graph is made up of nodes and arcs or directed links. When you can look at it in this diagram of ours. Each node corresponds to a random variable. So the random variables are A, B, C, and D, which are our nodes. And a variable can be continuous or discrete, as we looked before in the slide before. Each arc or directed arrow represents the causal relationship or conditional probabilities between random variables. These direct links or arrows connect a pair of nodes in the graph. These links represent that one node directly influences the other node. And if there is no directed link, which is our arrow, that means that the nodes are independent of each other. As you can see, A and C are independent of each other because there is no direct link connecting the two. And in the above diagram, A, B, C, and D are the random variables by the nodes of the graph network. If we are considering node B, which is connected with node A by a directed arrow, then node A is called the parent of node B. Node C and node A are very independent. That's why you can see node C is independent of node A because they don't have a directed link connecting them. The difference between naive Bayes and the Bayesian networks. Bayesian network models relationships between features in a very general way. If you know what these relationships are or have enough data to derive them, then it may be appropriate to use the Bayesian networks. A naive Bayes classifier may not be an easy model that describes explicit class of Bayesian network, wherever all classes, all are all conditionally independent because of this. Because because of this, there are bound problems that naive Bayes cannot solve. The example is given below. However, its simplicity makes it easier to apply, and it requires fewer data to get a good result in many cases. For this, undergoing through the probabilistic Bayesian model training would be a better prospect for a newbie. If you are new to these concepts, you should go under the probabilistic Bayesian models training, since they are somewhat related to machine learning algorithms and also data science course. One can also study them too for a better grasp on the aforementioned topics. For more information on the Bayesian theorem or Bayes theorem or Bayesian networks, you can follow the links that are provided in this slide or as in the description given below. Thank you, and please subscribe to our channel. Thank you.